Another example here of doing integration by substitution. How do we know we've got to use substitution? Well, we've got a function which is cos, and then here we've got another function. So we've got a function of a function. And when we get that situation going on, we try and simplify by letting u equals one of the functions. So here, if we let u equals 5t plus 2, that would certainly simplify our integration. So if we go to our template, our first thing is to make a suitable substitution. So let u equals 5t plus 2. The next step was to find du dt. So du dt is equal to derivative of 5t is simply just equal to 5, not t equals 5. And the derivative of a constant is 0. So du dt is equal to 5. My next step in the template was to make dt the subject. You can multiply both sides by dt and then divide both sides by 5. So multiply by dt and you get du equals 5 dt, and then we divide both sides by 5, and that gives us du over 5 equals dt. So the whole idea here is to make dt because we want to do a substitution not only for that but also for that. So we get du over 5 equals dt. Rather than have two steps here, as I've said before, when you've got a single entity there, which you have, you can just switch those two around and put the 5 down underneath and put the dt over on that side, and you'll get exactly the same as what you got there. Okay, so that's that step. Now we're going to turn this in, using our substitution, we're going to turn this into an integral with respect to u. These are t values, so we're going to make them into u values. So using the fact that we've got u equals 5t plus 2, we've got to find out the corresponding u values. Firstly, when t is equal to 0, and all we do is substitute t equals 0, 5 times 0 is 0, plus 2 is 2. And when t is equal to, the upper value here is 2, turn that into a u value by substituting in 2 times 5 is 10 plus 2 is 12. And our final step is to make the substitutions and then do the integral. So it'll become the integral. Now we're going to do the substitutions. The lower value was 2. The upper value is 12. Cos stays the same. This 5t plus 2 will be u, and dt is equal to 5u, so we get dt over here is 5 du over 5. So this integral, by using this substitution, is exactly the same as that one, but this is much easier to integrate than that. Okay, what do we do here? Square bracket. The integral of cos. We've got to go back to our table of integrals. What do we got to differentiate to get cos? Well, that's just sine of u. What happens to this 5 here? Well, it can just go over 5, so we can put that all over 5. And then that way it's just the integral of cos of u over 5 with respect to u. And the integral of cos is sine, and that's between 2 and 12. Okay, now we've remembered, haven't we, that when we're doing calculus with trig functions, our calculator must be in radian mode. So now we do the substitution, so that will be the sine of 12, not degrees but radians, over 5, minus the sine of 2 over 5. So with your calculator in radian mode, you actually find the sine of 12, divide by 5, put your answer down, minus the sine of 2, divide by 5, and when we get our answer we should get negative 0.289. So there we go, straightforward steps. Learn the template, find a suitable substitution for u, find du, dt, or in this case it was t, it could be x, whatever. Make dt the subject, so we rearrange that. Then we've got to find these values in terms of the new variable that we're changing. So we're changing it into an integral with respect to u, so we've got to actually change these into u values. And finally you do the integral. It's certainly a definite integral. Put the new n values in and we'll get our answer.